and welcome to the show. Today, we're talking about reinforcement learning, or RL. This is the area of machine learning where intelligent agents learn to make optimal decisions through experience. Think of a robot learning to walk, or an AI mastering a complex game. A huge part of making progress in RL is something called benchmarking. This means evaluating algorithms on standardized tasks and environments. It's how we track advancements, ensure we can repeat results, and find new research areas. So why are standardized benchmarks so important? Well, they give the RL community a common playing field to compare different algorithms. Without them, it's tough to know if a new method is truly better. Platforms like OpenAI Gym, DeepMind Control Suite, and the Arcade learning environment have been vital here, offering tasks from simple control problems to complex games. But RL benchmarking isn't without its hurdles. Reproducibility is a big one. Getting the same results reported by others can be tricky due to small changes in setup or even random chance. Then there's generalizability. An agent trained on one specific benchmark might struggle if the task changes even slightly. This is a major obstacle for real-world use. RL algorithms also often need a massive amount of data or interaction with their environment, which is known as sample efficiency. This makes training expensive and slow, especially if data is hard to get. Another challenge is bridging the gap between simulations and the real world. Simulators are helpful, but they don't fully capture real-world complexities. Safely testing RL agents, especially in areas like autonomous driving, is also a critical concern. We also need benchmarks for tasks that require long-term planning and memory, and for scenarios involving multiple interacting agents, known as multi-agent RL. Adding to this, many real-world systems need to make decisions fast, under real-time constraints, which traditional benchmarks don't always account for. And finally, how well can an agent adapt if the environment itself changes? This is called off-dynamics learning, and it's another area needing good benchmarks. Despite these challenges, the field is evolving. Researchers are creating more diverse and tougher benchmark suites. These include environments that test for safety, large-scale control, and better generalization. There is also a growing focus on using more robust statistics when evaluating results, so we're not just relying on single scores. Standardized libraries are also being developed to make comparisons fairer and results more reproducible, especially in multi-agent RL. We're even seeing early work on benchmarking for quantum reinforcement learning. Looking ahead, benchmarks will need to grapple more with real-world complexities like partial information, changing environments, and the need for AI to explain its decisions. The integration of human feedback into learning also brings new evaluation challenges. In conclusion, benchmarking is absolutely vital for pushing reinforcement learning forward. While current benchmarks have laid a strong foundation, the increasing complexity of AI systems demands more sophisticated evaluation. By tackling current limitations and embracing new trends, the RL community can better measure progress and guide the development of truly intelligent and reliable systems. The continuous development of new tools and methods shows a commitment to more rigorous and meaningful evaluation in this exciting field. That's all for today. Thanks for tuning in.